All right, today we're going to talk about is theoretical and experimental probabilities. So let's first talk about sample space. So sample space is a set of all possible outcomes of an experiment. So it says to list the sample space S for each of the following. So if you're tossing a coin, you only have two options. You have a head or a tail. So those are all the possible outcomes. And if you're to roll a six-sided die, your outcomes are 1, 2, 3, 4, 5, 6. Now, make sure you're reading this carefully. If you're drawing a marble from a bag, you have 2 red, 3 blue, and 1 white. And yes, I don't have white. It wouldn't show up on here, so I wrote it in black. All right. So now it says draw a tree diagram and list the sample space for tossing a coin. I forgot to list the space. Coin 3 times and list the sample space. So when you're doing this, it's important to realize that every time when you first flip your coin, you're going to have heads or tails. So that's always going to be the option. On your second flip, if you were to flip a head the first time, you're still going to get a heads or tails. So you could go here or here, and then here or here, and then same thing over here. So you're still going to get heads or tails no matter how many times you flip the coin. And then on your third, these are your options. So what we're going to do, and I forgot to do this before, but that's okay, I'll do it right now, is you're going to, one option is we could have heads, heads, heads. So I could go this way, this way, this way. And then I'm going to go heads, heads, tails. And then heads, tails, heads. Heads, tails, tails, and then come over here and do the same thing that I just did. All right, so when you're listing all of these, just make sure you are carefully organizing it, and then you know exactly what your options are. And sorry, I did not write this earlier. That was my bad. I did everything else, so all right, hopefully. And tails, tails, tails. All right, so that's your sample space. All right, so now you have theoretical probability of an event is the mathematical or basic probability that could be found with the formula. So theoretical probability or basic probability is the number of favorable outcomes, so whatever you're looking for, over the total number of outcomes. So if you were to pull a marble from this bag, the probability of picking a red is 7 out of 12 marbles. And the probability of blue would be 5 out of 12 total marbles. So theoretical is what should happen. Experimental is what actually happens. So experimental probability is the event is determined by carrying out a trial or the experiment. So if you roll a dice, what is the theoretical probability that you'll roll the number 3? Well, there's only 1 3 out of 6 total. And if you flip a coin 10 times, how often should, that means it's theoretical, you get a head? Well, you should get head 5 times, because if it were equal opportunity, in a sense, or equally likely, then it would be 5 heads, 5 tails. So that's theoretical, but that's not always what happens. So make sure you get that down. All right. So now it says the law of large numbers. Well, basically, in experimental probability, so the more you conduct a trial, that increases the experimental probability as it's getting closer to what should happen, which is your theoretical probability. So, which experiment would be closest to the theoretical probability? Mary rolls the dice 6 times to see how often she gets the sum of 4, or Marty rolls the dice 60 times to see how often, I think that's supposed to be Mary, but that's okay, how often she gets a sum of 4. It could be Marty too. Well, since this is a bigger number, we're going to get closer to theoretical, option B. All right, so now let's look here. And if you don't play cards regularly, or if you haven't played cards, then you'll definitely need to make sure you understand this. But there's standard deck has 52 cards, and these are all of the options you could potentially have. So you should have 26 red and 26 black. So these are all red. And then these are all black. You should 4 suits. So these are your suits. Let's see. All right, suits. So these are your suits, which would be diamonds, clubs, hearts, and spades. So we have 4 suits. And then within each suit, there's 13 cards. So you have 13 total cards. Ace. And then you go 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have your face cards. Your face cards are Jack, Queen, King. So all of these are face cards. All right. Let's see. Red cards are hearts and diamonds. And black cards are spades and clubs. So I tried to at least label it for you. So again, if you are not familiar with playing cards or all the cards in a deck, I would definitely make sure you understand all of those and write it down. All right. So now we're going to look at our information. And so Amanda recorded the suit of the card she picked and then replaced the card. The results are in the table below. So based on her results, what is the experimental probability of selecting a heart? So this is the actual. So you want to look at what actually happened. All right, so the actual result is when she did this, she got 9 out of hearts, which should have 30. Or total, sorry. So she has 9 out of 30, which is 3/10. All right, so she got 9 out of 30. That's where we got that from. All right, so now the theoretical is what should happen. So theoretical is, well, for hearts, she should get 13 out of 52, which is 1/13. All right, so now what I want you to do is I want you to finish these using this information, using this information and this for experimental, and then using this information for theoretical. All right, so now let's go ahead, let's do this one. And it says you shove all of your socks in the drawer without worrying about finding matches. You randomly picked 20 individual socks and recorded your results below. Now I already wrote the total in here for you, but it's also listed right there. All right, so what's the experimental probability? So this is your actual results. And so the probability, that's how you say it, the probability of picking a white. So we're going to look here at white, which is 12 over 20. And then don't forget to simplify that. And the probability of blue, so that's 1 out of 20. And then the probability of green is 3 out of 20. And the probability of pink is 4 out of 20. And we can actually simplify this more, which is 1/5. All right, so that's just looking at your table and then figuring it out. Okay, so this one is theoretical probability. So you've got 16 pairs of white, 2 pairs of blue, 6 pairs of green, 8 pairs of pink. What's the theoretical? So this is what should happen. And this one was what actually happened. All right, so go ahead, try these, and then notice the difference between the numbers. I will give you a hint. This was 64 socks if you added correctly. All right, now basic probability. So again, this is just understanding part over total. That's how I like to think about it. So part over total, or part over whatever is happening, or part over event. So however you want to put, however you want to think about it, but they do have here favorable over total, so that's the part you're looking for. All right, so consider a jar of marbles. Okay, I'm going to go here. Consider a jar of marbles with 5 blue, 8 red, 10 green, 5 white, and 9 purple. What's the probability of choosing a red marble? So first you need to make sure you add all of them up, and you would get 37 total. So the favorable would be 8 out of 37. Now this one says a green or white marble. So since it says or, you've got 10 green, and then you have 5 white. So we're going to add those together to get 15, but your total is still going to be the same in this case. All right, the probability of picking a yellow marble. Well, there are no yellow marbles listed, so it's 0 out of 37, which equals 0. Either would be acceptable. All right. And then it says not a blue marble. So you're going to add up all the ones except for the blue. So you're going to add up these together, or you can take your total, 37, and go 37 minus 5, and that gets you 32. So either way works. I prefer just the subtracting from the total. All right, and then E is a purple, green, or red marble. So we got purple, green, or red. And since you're going to add those together, since it says or, and then your total is 37. So you're going to get 27 out of 37. All right, I want you to try this one. And then again, you can use your card chart. It tells you here, you can use a card chart of the other one. All right, so now this last part, I want you to go ahead and try. I did list the sample space there, so I knew I listed it somewhere. All right, and then here it just says consider rolling a two six-sided dice, 36 possible outcomes. So all of these right here are your outcomes, and then the probability of rolling a sum of 10. So you can think of all the different ways you can get a sum of 10. So you can roll one way here, one way here, and one way here. So you would be 3 out of 36 total. So I'll get you started with that one, which is 1/12. All right, and then like I said, I got you started with these here, so you can go ahead and answer that. Just make sure you're reading them carefully, and then if it's asking for the same number, that would be like your 5, 5, where you would have to roll a 10. And if it's a 6, 6, that would be a 12. A 4, 4 would be an 8. So that's what it's asking for that one. All right, so go ahead, complete those. And then that is your theoretical and experimental probability.